Everybody, Mr. Gustin back in the physics classroom. Here, we're going to talk today about our three free fall labs: our reaction time lab, our hang time lab, and our how high lab. I want to kind of talk about some of the similarities between these activities or labs and the common thread between those labs and activities, because I think it's important for us to understand like the story being told about the different labs and how we can use their similarities to help us in future free fall type scenarios and future physics scenarios. So let's start with the reaction time lab. I've got my picture drawn. This is me, not very well, but me kind of catching my meter stick after it's dropped. It's dropped from rest. So what I'm going to also start doing is labeling some things that I know. So this thing is dropped from rest. The initial velocity is 0 meters per second. It falls a distance or a displacement of change in y. This is what I measured in the lab. What I also know is that the acceleration is equal to g, but it's downward, right? So it's g, it's 9.8 or negative 9.8 meters per second squared downward. These are the things that I know about this motion, okay? I'm just kind of starting from the beginning. So I've got a picture, I've got my known variables. What I don't know, I have no idea what the final velocity of this thing is as I catch it. I don't really know that. And I certainly don't know time, because that's what I'm trying to solve for, right? This is my reaction time, and this is my goal. So like every other lab that we do, we want to make sure we draw an FBD. What forces are acting on the object? So I'm going to go ahead and actually take this meter stick right here and simplify it down to one little point, and just say, if this whole meter stick is this point, what are the forces acting on the meter stick before I go ahead and catch it? So as it falls through the air, the only force acting on it is the force of gravity. Because it has this force on it, we call this motion free fall. Anytime an object only has the force of gravity acting on it, well, forget air resistance, we call it free fall. So this is one of those cases, because after this meter stick is dropped, it's in free fall. So my initial velocity is 0. We saw our physics friends break physics on like day 2 when they moved that ring out of the way and the marker hung in the air for a split second. Its initial velocity was 0. So we know when we drop something, initial velocity is 0. Final velocity is not 0. It's not after we catch it. The final velocity is still while it's in free fall, the instant before we catch that meter stick, okay? So this is my setup. These are the things that I have. I need to find reaction time. What I have to consider now is, which equation should I use? Well, that means I need to go ahead and get my handy-dandy equation sheet and think about the 3 equations we have for free fall. The first is final velocity equals acceleration times time plus initial velocity. The second one is change in position is initial velocity times time, 1/2 AT squared. And the third is final velocity squared, initial velocity squared, plus 2a change in position. Now, the first thing that I'm going to do is adjust these equations a little bit. Because while I'm in free fall, these equations might take, or I could like substitute in different variables. While I'm in free fall, none of these a's are actually acceleration. They're all g's. I'm in free fall. The only thing accelerating them is gravity. So I can think about those in terms of g. And I'm not actually moving in the x direction or horizontally. If I think about it like a Cartesian coordinate system, I'm moving vertically. So I can change all of these x's into y's, or changes in vertical position. So I'm going to do that. All right? Now, I need to find time. I know initial velocity, I measured displacement, and I know acceleration. If I look at these 3 equations, which of these equations has initial velocity, displacement, and gravity in it that will help me find time? I kind of feel like I'm doing the Dora the Explorer thing right now, but it looks like the second equation has initial velocity, it has time, it has acceleration, it also has time, it's got position. The cool thing about this expression is when I write it over here, y equals v naught t plus 1/2 g t squared. The initial velocity is 0. When the initial velocity is 0, this simplifies down to change in position equals 1/2 gt squared, and you can go ahead and solve for time. The big thing here was that at the beginning, at the very top of the motion, we saw the initial velocity was equal to 0. How cool is that? Let's think about the hang time lab. The hang time lab is really similar to the reaction time lab, except we're going up before we come back down. All right? If I go ahead and map this motion, my person, or the person jumping, myself, goes up, stops, and then comes right back down right before or right as they hit the ground. Well, the reaction time lab was basically just this motion right here. This motion falling from a peak was the reaction time lab. It's the exact same motion. Going to a peak, coming to a rest, and falling back to the ground is the reaction time lab. It's the kind of scenario when anything starts at rest at an apex and falls to the ground. But in this case, we went up and we came back down. So we have to consider, what are some things we know? Well, we were looking for hang time. So again, we're solving for time. So time is our is the hang time. This is our goal. I measured change in y. This was measured off the meter stick. I also secretly know acceleration always when I'm in free fall, negative 9.8 meters per second squared. But now I'm stuck because I don't really know initial velocity. Like, I don't know the speed at which I leave the ground with. I don't know what that is. And I don't know the speed at which I hit the ground with. That's difficult for us then to reconcile. Which equation do I choose? If I look over here at these equations, I either need initial velocity or final velocity for all of them. And I don't have that. So I've got to get creative here. And the good news, when I get creative, I can actually just split my motion in two. And I can only worry about this second half of the motion, or only worry about the first half of the motion. But I'm allowed to just separate out and say, I'm going to examine this part of the motion. So I'm familiar with the reaction time lab. So I'm familiar when objects reach an apex and come back down. Well, then let's just examine this motion after I'm coming back down. Let's examine this motion after I've jumped up, hit the wall, and on my way back down. So if I think about that motion, the initial velocity, I don't know what that is. I do know the velocity at the apex, though. The velocity at the apex is 0 meters per second. This helps me because when I pick an equation now, I have this velocity present. Let's just call the velocity at the apex my initial velocity. It's where I start. Okay, well, if this is where I start, well, that means my change in y, or my initial y position, is up here, and my final y position is down there. If I start here, I'm going to fall in this direction. It's a good thing we measured our change in y. If I know change in y, I know acceleration, I've got an initial velocity and time. Well, folks, this looks just like my reaction lab from before. So I'm going to go ahead and use my change in y is equal to initial velocity, or apex in this case, times time, plus 1/2 gt squared. I've gone ahead and already plugged in my specific variables for this lab. So what's the velocity at the apex? Well, that's 0. Change in y is equal to 1/2 gt squared. Now I can solve for t, and when I do solve for t, what I have to remember is that this t is from the apex to the ground. I wonder what I have to do to that time in order to find the total hang time. Interesting. These two labs are really about time. Can I use my measurements to find time? Over here, the third lab, the how high lab, is going to be all about height, change in y. So if I think about my picture, it's right here. I throw something up with an initial velocity upward. Initial velocity going this way, final velocity going this way, downward. This is my picture, right? At the very top, this is my velocity of the apex. It's 0 meters per second. Okay, so I'm trying to find y. I can't measure this time. This is my answer to the question, how high? This is my goal. What did we measure in this lab? We measured time. This was measured. We measured time all the way up and down. As it went up and down, we measured that. We always know acceleration when we're in free fall. It's negative 9.8 meters per second squared. We can go ahead and draw our FBD. The force of gravity pulls it down. Even though it's going up and slowing down, force of gravity. Anything else that we know? Well, hopefully at this point we're aware, like, hey, the velocity at the apex in this motion is 0 meters per second. And we're trying to find change in y. Folks, these variables, these unknown variables look really similar to me. This looks like the exact same, this. It looks like this motion again. I see this motion where I go up and I fall back down. This reminds me a lot of the hang time lab where I only analyzed the second half and then I was able to double my time to find the total hang time. Well, this time, like the height is here. This is my change in y. I wonder how long it takes me to go half the distance or to fall from the top to the bottom. This is something I'm considering. So if I only examine the second half of the motion from the apex to the ground, well, my initial velocity is then 0. My acceleration is still negative 9.8. The time I measured really should be like divided by 2 in order to get me the time to ground from the apex. And then my change in y is my goal. I can set up the exact same equation. I can say, hey, change in y is equal to the velocity at the apex, initial velocity, times time, plus 1/2 gt squared. Well, that's 0. Remember, the time I need to use is the time from the apex to the ground. So this is my time. I can't use this time. I need to divide it by 2. This will help me work through figuring out my delta y. My change in y will be equal to 1/2 gt squared if this t is that half time, that time from height to the ground. Folks, I hope you're starting to see it. Like, these types of motions, these free fall motions, are very, very similar. That this unknown, this little hidden variable, that the velocity at the apex is 0, is super important to us and allows us to kind of examine different parts of our motion that will hopefully help us understand more holistically the motion that we're seeing here. Okay? I hope this little video helps you out with your labs, or understanding your labs, or finishing up your labs. So go ahead and do that for me. Solve for your reaction time, your hang time, and how high the bleachers were outside. And I will see you all in class later. See ya!